So moving on to the third section of the NEA, we've got the section headed System Realization. So I've got a nice clear title across the top to say that I've started the next bit. I've repeated my system block diagram, my final one, so there can be no question about whether or not I've made any alterations or which diagram is the one that I'm working from. So I've literally just copied and pasted it from further back in the document. I've included it, I've made sure I've got my input process outputs labelled because that has an impact on my marks, and I need to move it from a circuit diagram to this stage here. Now I've tested all of the different elements, but how do you actually combine it into a final circuit? Now for the line follower, these were the 5 different tests that needed to be completed for the 5 blocks. We had the on-off switch, we had the LDR, which was used as part of a potential divider, and the output from the LDR goes into the transistor. When the transistor is turned on, then it allows a current to flow from the collector to the emitter, and I put a bulb in there to show the load for the transistor. I showed a motor running on 9 volts, which is what we'd have going through the transistor. And separate to that, I had an LED, because the LED is just going to be on all of the time to bounce light off the black and white surface so that the LDR can get a better reading from whether or not it's above the black line. So I've got 5 different mini circuits and I need to combine it into one circuit. So my starting point is I need to decide which bits I don't need, basically. So looking at this circuit, I only need one 9 volts and one 0 volts. So I'm just going to cross that one out, I don't need it. Cross that one out, I don't need it. Same goes for that one. That one. That one. That one. And those. Don't need any of those. Equally, the voltmeters are not actually a component within the circuit. So I don't need those. So I'm busy narrowing it down to which components I actually need. Well, this input voltage was put there to represent the voltage coming from the potential divider, so I don't need that. And the bulb was put in as the load for the transistor instead of the motor, so I don't need that. Is that everything? So I've got my power supply. Oh, I don't need that bulb there either, because it was there as the load for the switch. So I've got my power supply to my switch, going to my potential divider. My potential divider goes to my transistor, which works on my motor, and then right, yep, that's fine. So it's then a matter of drawing the circuit from there. So looking at it on Circuit Wizard, I can do a similar thing. Rather than crossing out and drawing by hand, I can go through, I can take those original diagrams, I can delete the pieces I don't need, which might make it a little bit easier for you to visualize. Motor, don't need you. Okay, so it's just a matter of moving everything into place. So I've got my 9 volts switch. So I'm going to dump that here. Now in reality, it's an on-off switch. I prefer to just have it as part of the positive rail. So rather than having it vertical, I'd rather it was horizontal and just placed it there. I'm just going to stick my 0 volt rail down there because I have to remember that everything's going to get connected back to it. So first thing after the switch is going to be my potential divider. Could be the LED combination. I tend to not do that because I tend to put the outputs on the right hand side. I think it makes it clearer, easier to understand what's going on. So there's my potential divider, and the point where I measure my voltage signal, that gets connected into my transistor. So I can grab that, bring it down, put it in. My transistor, the collector, needs to be connected to my motor. So I can bring that round, drop that in place, and the top of the motor should be connected to the positive rail. So that drops in there. And the emitter from the transistor should be connected to the negative rail, so that drops in there. After that, I've got my LED combination, so that is literally going in parallel to everything else, so I can drop it onto the end. That's messy, don't like that. And the last thing that I need to do, and this is a bit of a you need to be aware of thing, is okay, I've done all of that, but what I haven't done is I haven't included the diode that will protect the transistor from the motor and the back EMF from the motor. So I just need to grab a diode, drop it in like that. So that is my circuit put together. And when you've done that, you can either do it on Circuit Wizard. They don't need to see the stages, but actually if you went back to this and you actually had this in your document, they would see the way you've been working, and then they'd be able to say, okay, so we've done that, and then you can say, and that has led to, let's see if we can copy and paste today. This circuit here. A little bit of text possibly, it's not actually required, but a little bit of text saying, look, this is what I did, this is how I got it, this is, you know, the stages I went through. But in reality, that information is there. So that would be how you would finalize your circuit. Slight afterthought, obviously the last thing you should be doing once you've put your circuit together, you should actually be checking that it works. So I'm going to put my switch down, I've got my voltage bars. If my light level goes down, let's move that up there out of the way. If my light level is very, very bright, my transistor is on. I've got 9.84 millivolts there, and my motor is turning. My LED is on anyway. And if it gets dark because I'm above the line, then my motor stops turning because my voltage here is now down to 7.749 volts. So that's dropped down. So I now know that that will turn this on and off according to the circuit simulation, and that my LED will turn on and stay on all of the time. So another one to add would be a diagram of it working, to say, yep, I've done it, it satisfies everything.